It will take 21 years and $1 billion. But if all goes well, a University of Arizona scientist will make history when a NASA spacecraft returns part of an asteroid that could one day impact Earth.
But it's also a mission that could be derailed, strangely enough, by what's been happening in Ukraine. It all began 9 years ago when a Professor Dante Loretta, got a phone call.
The history goes back to 2004. I was a young assistant professor here at the University of Arizona, and I got a call from the lab director, Mike Drake.
Then assistant professor Dante Loretta was asked if he wanted to work on a mission to space.
And I thought about it for a little while, saying, I don't know, I don't have tenure, it's a big risk, a long timeline. But absolutely, I can't turn down this opportunity.
Now Loretta leads a team of 100 U of A students and 60 full-time personnel out of this building in Tucson. It's an international effort involving NASA, Lockheed Martin, and hundreds more to launch one of the most complicated and ambitious space missions of all time.
It is a full-time job and then some, absolutely.
The mission is called Origins Spectral Interpretation Resource Identification Security Regolith Explorer, or OSIRIS-REX for short. The goal, to send an unmanned spacecraft to the near-Earth asteroid Bennu and return to Earth with a little piece of it. That may help scientists then discover the origins of life on Earth.
We feel that early on, asteroids like Bennu may have landed on the surface of the Earth and seeded the surface with all of the materials that you're going to need to ultimately create the origin of life.
In 2016, the OSIRIS-REX will lift off from Cape Canaveral, Florida. In 2018, it catches up to Bennu and begins to study it up close.
We're looking for its mass, its rotation state.
The asteroid is no stranger to Earth. Bennu passes by once every 436 days, and scientists expect that it might get a little bit too close sometime in the next century.
In about 120 years, we think there'll be a very close approach to the Earth. Ultimately, it may come right down to the surface and impact.
And part of the OSIRIS-REX mission is to determine how an asteroid like Bennu could be steered away from our planet, because impact would be unimaginable, even from an asteroid just a half a kilometer wide.
So that would create an explosion of about 3,000 megatons on the surface of our planet. Just for comparison, the nuclear bombs in World War II were about 50 kilotons. So we're talking thousands of times more explosive power than a nuclear weapon.
The mission's main objective begins about a year after it arrives. OSIRIS-REX will carefully move close to the asteroid for a touch and go. OSIRIS-REX can't land on Bennu because it doesn't have enough gravity to stay put.
So the danger was the spacecraft would tumble or bounce away.
Instead, it will deploy its collection arm to capture some of Bennu's surface.
So we'll fly in, contact the surface for 5 seconds, blow down high-pressure gas to stir up all the soil on the asteroid's surface, catch it in a big air filter, and then 5 seconds later get away from the asteroid.
And 9 years from now, whatever OSIRIS-REX collects will be returned to Earth and then safely studied at this lab in Tucson.
We do not expect to bring back anything hazardous to the Earth's biosphere.
A countdown clock in the building's lobby showed 779 days, 5 hours, and 9 minutes until liftoff. And it will all come down to the moment OSIRIS-REX makes contact with Bennu.
21 years, $1 billion, comes down to 5 seconds of contact with the asteroid surface. It'll be a long time coming. It'll be my career on the line, so I will be as prepared as possible, but as I always say on this project, ready or not, here it comes.
And as if there wasn't enough pressure already, Loretta's ready or not may depend on an unexpected political issue. U.S.-Russian relations, not exactly at a high point after the downing of the Malaysian airliner over Ukraine last week.
We have Atlas ignition. 2, 1.
But there has been a lot of discussion about the fact that our Atlas V launch vehicle uses the RD-180 engines that are manufactured in Russia.
That's right. The Atlas V rocket used in NASA's launches like this one are powered by Russian-made rocket engines, the same rocket carrying OSIRIS-REX into space.
Right now, everything looks good. We're on schedule. We expect our rocket engines to show up on time. Fingers crossed.
So far, the White House has mandated sanctions against Russia to not include exported rocket parts. That's so far. Now, a 39-day launch window for OSIRIS-REX begins September 3rd, 2016. If you'd like more information, of course, you can go to our YouTube channel at youtube.com/myfoxphoenix.
Not an